going over the solutions from exercise 12.1 from chapter Surface Area and Volume. So in the first question they're given that two cubes each of 64 centimeter cube are joined end to end. We need to find the surface area of the resulting cuboid. So they've given that the volume for each singular cube is 64 centimeters, 64 centimeter cube. And we know that the volume of a cube is given by the formula a cubed, which is equal to 64, where a is the length of the side of the cube. So when we isolate a, we will get a is equal to the cube root of 64. So the value of a would be equal to 4. So that means the width of the cube would be 4, and the height of the cube would be 4. Next, they're asking us to find the surface area of the resulting cuboid. So that means its length would be 4 plus 4, so it'll equal 8. And we know that the formula for finding the surface area of a cuboid is 2 times L into B plus B into H plus H into L, where we know that the breadth is equal to 4, height is equal to 4, and the length of the cuboid would be 8. So it would be 2 times L into B, which is 8 into 4, which is equal to 32, B into H, 16, H into L, 32, and 2 times 32 plus 16 is equal to 2 times 80. So 80 times 2 is equal to 160 centimeters squared, which is equal to the surface area of the resulting cuboid. In the second question, they've given that a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeters. So the diameter is 14 centimeters. And the total height of the vessel is 13 centimeters. So the total height is equal to 13 centimeters. Since I've given that the diameter of the hemisphere is 14, that means its radius would equal 7. That means the height of the hemisphere would be 7 centimeters. So the height of the cylinder would be 13 minus 7, which will give us the height of the cylinder. And 13 minus 7 is equal to 6. So the height of the cylinder would be 6 centimeters. They're asking us to find the inner surface area of the vessel. The inner surface area of the vessel would be the CSA of the hemisphere plus the CSA of the cylinder. We know that the formula for finding the curved surface area of a hemisphere is equal to 2 pi r squared. So 2 pi r squared plus, we know that the CSA formula for the cylinder is 2 pi r h. Here we can take 2 pi r commonly outside. So 2 pi r, on the inside we'll have r plus h. So here it will be 2 times pi, which is 22 over 7, times the radius, which is equal to 7, times r, which is 7, plus the height, which is 6. So 7 and 7 will get cancelled, so 44 times 6 plus 7, which is equal to 13. And 13 times 44 will give us 572 centimeters squared, which is the inner surface area of the given solid. In the third question, they've given that a toy is in the form of a cone of radius 3.5 centimeters. So this value and this value is equal to 3.5 centimeters. And the total height of the toy is 15.5 centimeters. They're asking us to find the total surface of the toy. Since the height of the hemisphere is 3.5 centimeters, that means the height of the cone would be 15.5 minus 3.5, which is equal to 12. And since they're asking us to find the total surface area of the given figure, we know that the TSA of the whole figure would be the CSA of the hemisphere plus the CSA of the cone. So the CSA of the hemisphere would be 2 pi r squared, and the CSA of the cone would be pi rl. So we need to find the value of L first. So we know that L squared is equal to r squared plus h squared. So L squared is equal to r squared, which is 3.5 squared, plus h squared, which is 12, which is equal to 144. And 3.5 can be written as 7 over 2 squared plus 144, where we will get 49 by 4 plus 144. So 144 times 4 will give us 49 plus 576 divided by 4, which is equal to 625 divided by 4, and which is equal to L squared. So the root will go to both the numerator and the denominator. So the value of L would be 625 root and root of 4. So root of 625 would equal 25, and the root of 4 is equal to 2. So the value of L would be 12.5 centimeters. So now in this formula, where we have 2 pi r squared plus pi rl, we can take pi r commonly outside. So pi r times 2r plus L. So here we know the value of pi, which is 22 over 7, times 3.5 over multiplied by 2 times the radius, which is 3.5, plus the value of L, which is 12.5. So 7 and 3.5 will get cancelled, so 0.5. And 2 times 3 is equal to 7, so 7 plus 12.5 times 22 times 0. So 22 times 0.5 is equal to 11, so 11 times 12 plus 12.5. So we will get 19.5 times 11. So 11 times 19.5. So when we multiply this, we will get 214.5 centimeters squared, which is equal to the total surface area. In the fourth question, they've given that a cubical block of side 7 centimeters is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? And find the surface area of the solid. So the hemisphere can occupy the whole side of the cube, meaning that the diameter of the hemisphere, the greatest diameter of the hemisphere, would equal 7 centimeters. So that is the answer to the first part of the question. Second, they're asking us to find the surface area of the solid. So the surface area of the solid would equal the curved surface area of the hemisphere plus the area of the cube minus the base area of the hemisphere. So we know that the CSA of a hemisphere is equal to 2 pi r squared. The area of the cube is equal to 6a squared minus the base, which is equal to pi r squared. So 6a squared would equal 294, which is basically 6 times a squared. The value of a is 7. So 6 times 49 is equal to 294. Next, we need to find the CSA of the hemisphere, which is 2 pi r squared. So 2 pi r squared is equal to 2 times 22 by 7 times 7 by 2 the whole squared, which is the radius, because the diameter is 7, so the radius would be 7 over 2. So 7 and the squared will get cancelled. This and this will get cancelled. So 2 pi r squared would equal 77 centimeters squared. Next, the base area of the circle, which is the base of the hemisphere, would be pi r squared, which is 22 over 7 times 7 by 2 times 7 by 2. 2 and 22 will get cancelled, 7 and 7. So we will be left with 77 divided by 2. So the surface area of the solid would be 294 plus 77 plus minus 77 divided by 2. So we will get 294 plus 77 minus 38.5. So 371 minus 38.5, which is equal to 332.5 centimeters squared. Question they've given that a hemispherical depression is cut out from one face of the cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So, we can say that the surface area of the solid is equal to the area of the cube plus the curved surface area of the hemisphere minus the base of the hemisphere. So the area of the cube would be 6L squared. So we're going to take the side of the cube to be L. So it will be 6L squared. Next, we need to find the CSA of the hemisphere. So the CSA of the hemisphere is equal to 2 pi r squared, where we're going to take the diameter of the hemisphere to be equal to the side of the cube. So since we can say the diameter is equal to L, so the r radius would be L by 2. So the formula for the CSA of the hemisphere is 2 pi r squared, so 2 pi times L by 2 the whole squared, which will give us 2 pi by L squared by 4. So this and this will get cancelled, so we'll be left with pi L squared by 2. Next, the base area of the hemisphere would be pi r squared, so pi times L by 2 the whole squared, which is equal to pi L squared by 4. So now the surface area would be area of the cube, which is 6L squared, plus area CSA of the hemisphere, which is pi L squared by 2, minus the base, which is pi L squared by 4. So here we can multiply this so that they both have the same denominator. So when we do that, we will get 2 pi L squared by minus pi L squared by 4. So 2 pi L squared minus pi L squared will give us pi L squared by 4. So we will have 6L squared plus pi L squared by 4. So here we can take the common terms outside. So we can take L squared outside, so inside we'll have 6 plus pi by 4. When we simplify this, we will get L squared plus 24 plus pi by 4. So since 4 is on the denominator, this would be the same as L squared by 4 times pi plus 24, which is the answer to the question. In the sixth question they've given that a medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeters and the diameter of the capsule is 5 millimeters. We need to find the surface area. So the radius of the 2 hemispheres is equal to 5 millimeters. The length of the whole capsule is 14 millimeters. We need to find the height of the cylinder first. So the height of the cylinder would be 14 minus the radius, which is 5 by 2. times 2. So 14 minus 5 is equal to 9 millimeters, which is the height of the cylinder. Now they're asking us to find the total area of the capsule. The total area of the capsule would be the CSA of the cylinder plus the CSA of the two hemispheres. So first, let's find the CSA of the cylinder. So the CSA of the cylinder is equal to 2 times pi, which is 22 over 7, times r, which is 5 over 2, times h, which is 9. So 2 and 2 will get cancelled. We will be left with 990 divided by 7 millimeters squared. Next, we need to find the CSA of the hemisphere. So the CSA of the hemisphere is equal to 2 times pi, which is 22 over 7, times r squared, which is 5 by 2 times 5 by 2. So when we simplify this, we can cancel 2 and 2, and here we'll simplify 22 and 2. So we'll be left with 275 divided by 7 millimeters squared. So the CSA of two hemispheres would be 275 times 2, which will equal 550 by 7 millimeters squared. So now the total area of the capsule would be the CSA of the cylinder, which is 990 by 7, plus the CSA of the two hemispheres, which is 550 by 7. Since they both have the common denominators, we can add it. So we'll get 1540 divided by 7, which is equal to 220 millimeters squared. In the 7th question, they've given that a tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meters and 4 meters, respectively, then the slant height of the top is 2.8 meters, and they've given that the diameter of the cylindrical part is 2.1 meters. Sorry, the height is 2.1 meters, and the diameter of the cylindrical part is equal to 4 meters. And the slant height of the top is 2.8 meters. We need to find the area of canvas used for making the tent. Also, we need to find the cost of the canvas of the tent at the rate 500 rupees per meter squared. And they're also saying that the base of the tent will not be covered with the canvas. So first, we need to find the area of the canvas. To find the area of the canvas, we need to find the CSA of the cone plus the CSA of the cylinder. So the CSA of the cone is pi RL. So 22 by 7 times radius, which is 4 divided by 2, so 2 times L, which is 2.8, which will give us 17.6 meters squared. Next, the CSA of the cylinder. So the CSA of the cylinder is equal to 2 pi RH. So 2 times 22 by 7 times 2 times 2.1. 7 and 2.1 will get cancelled, 0.3. So when we multiply all of this, we'll get 26.4 meters squared. So the amount of canvas, the area of the canvas would be 26.4 plus 17.6, which will give us 44 meters squared. So now they're asking us to find the cost of the canvas of the tent at 500 rupees per meter. So for the cost, we just need to multiply 500 times 44, which will give us 22,000 rupees. In the 8th question, they've given that from a solid cylinder whose height is 2.4 centimeters and diameter is 1.4 centimeters, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter. So the total surface area would equal the CSA of the cylinder. So the CSA of the cylinder plus the area of the base of the cylinder plus the CSA of the cone. So first, let's find the CSA of the cylinder, which is equal to 2 pi r/h. So it'll be 2 times pi, which is 22 over 7, times r, which is 1.4 divided by 2, times height, which is 2.4. And they've given that the diameter is 1.4 and the height is 2.4 centimeters. So the radius would be 0.7, so 2 times 22 by 7 times 0.7 times 2.4. So we'll be able to cancel 7 and 0.7, which is 0.1. So we'll be left with 2 times 22 times 0.1 times 2.4, which is equal to 10.56. Next, we need to find the area of the base of the cylinder, which is equal to pi r squared. So 22 by 7 times 0.7 times 0.7, which will give us 1.54 centimeters squared. Next, we need to find the CSA of the cone, which is pi r l. We know that the height is 2.4, r is 0.7, so L squared is equal to 2.4 squared plus 0.7 squared. So L squared is equal to 5.76 plus 0.549. L is equal to root of 6.25, which is equal to 2.5. So now pi RL is 22 by 7 times R, which is 0.7 times 2.5. So we will get 5.5. So the total surface area would be 10.56 plus 1.54 plus 5.5, which is equal to 17.6 centimeters squared. So when we round it off to the nearest 10th place, we will get 18 centimeters squared. In the 9th question, they said that a wooden article was made by scooping out a hemisphere from each end of a solid cylinder, as shown in figure. If the height of the cylinder is 10 centimeters, and if the height of the cylinder is 10 centimeters and the base radius is 3.5 centimeters, we need to find the total surface area of the article. So the total surface area of the article would be the CSA of the cylinder plus 2 times the CSA of the hemisphere. So first, the CSA of the cylinder, which is equal to 2 pi r/h. So 2 times 22 by 7 times radius, which is 3.5, times height, which is 10. So 2 times 22 by 7 times 35. 7 and 35 will get cancelled. 44 times 5 is equal to 220. Next, we need to find 2 times the CSA of the hemisphere. So 2 pi r/h, 2 times 22 by 7 times 2 pi r squared, so 3.5 times 3.5, 0.5, so 44 times 0.5 times 3.5 is equal to 77. 77 times 2 is equal to 154, so the total surface area would be 154 plus 220, which is equal to 374 centimeters squared.